Last problem, number 3. Now this time we are given an initial condition, but we know we just need to start by solving this differential equation for y. Whenever I see a y prime, I'm just going to rewrite that as dy dx. So we've got x, y, dy dx is equal to x squared plus 1. And we're going to use this cross multiplication method to get all of our y terms on one side and all of our x terms on the other, essentially to separate this equation. And so we need this dy dx to be on the one side, so let's divide both sides by xy. And when we do that, we're left with dy dx is equal to x squared plus 1 divided by xy. All right, so we've got our dy in this numerator. We need just our y terms in the denominator. We've got our dx in the denominator, so we need just our x terms in this numerator. So the only term that needs to switch levels is this x. We need this x to be in the numerator. And to get this x in the numerator, well, we know this is kind of like an x to the power of positive 1 in the denominator. So to bring it up to the numerator, we're going to negate that exponent, meaning this is going to become a 1 divided by x in the numerator. And so that's going to look like dy dx is equal to the quantity 1 over x times x squared plus 1 divided by y. Okay. Now that we've got all of our x's in the numerator, y's in the denominator, now we can cross multiply and say that y dy is equal to the quantity 1 divided by x times x squared plus 1 dx. And so now we're going to integrate both sides now that we have this separated. So we have the integral y dy is equal to the integral of 1 over x times x squared plus 1 dx. We can integrate y dy. We know that that's just going to be y squared over 2 plus one of our constants. Over on the right-hand side, I'm sorry, this is supposed to be a dx. We don't want a dy over here. We can't integrate this as is, but we can distribute. We can distribute this 1 divided by x to both of these terms. And so 1 over x times x squared is really just x squared over x. I'll write this out. X squared over x plus 1 over x dx, which is really the integral of x squared divided by x is just x. So we just have x plus 1 over x dx. And now we can integrate this. The integral of x with respect to x is x squared over 2. What's the integral of 1 over x? We remember that that's that natural log of the absolute value of x. And then plus our second constant of integration. Okay. So we know we're going to subtract the c1 from both sides, and let me just write this: y squared over 2 is equal to x squared over 2 plus the natural log of the absolute value of x plus c. We're just subtracting these two constants. We know this is going to leave us with another constant. Okay, So now our goal is to isolate this y. So let's multiply both sides by 2. We're left with y squared is equal to, so multiplying everything by 2. This first term is just going to be x squared. This will become 2 times the natural log of the absolute value of x. And then we know that 2 times a constant is just another constant. Finally, we have a y squared. To isolate y, we're taking the square root of both sides, and so y is equal to the square root of x squared plus 2 times the natural log of the absolute value of x plus c. And let's not forget what happens when we take a square root. So if I have an equation like x squared is equal to 4, well then I know x is really equal to the square root of 4, but not just the square root of 4, but a positive and a negative square root of 4, which will leave me with 2 and negative 2. And in the same way, whenever we take a square root, we have an equation, we take a square root, we're going to be left with the positive and negative square root. Okay, so this is our equation. So let's just put a box around this. We're not quite done yet, but this is our equation. If we weren't given an initial condition, this would be our final answer. But we were given this initial condition that y of 1 is equal to 2. Okay, so we've got y is equal to, I'm just rewriting this over here, the square root of x squared plus 2 ln absolute of x plus c. Okay, our initial condition, y of 1 is 2. So now we're plugging 1 into this equation, into this expression on the right-hand side, and setting that equal to 2. And so we get 2 is equal to plus or minus the square root of 1 squared plus 2 times the natural log of the absolute value of 1 plus c, and we want to know what that plus c is. Let's simplify. 2 is equal to the square root plus or minus the square root of 1. 2 times the natural log of 1, well the natural log of 1 is just 0, and so we're just left with 1 plus c. And so what does this plus or minus really mean? Well, it really means that this represents 2 different equations. This represents 2 is equal to the square root, the positive square root of 1 plus c, and 2 is equal to the negative square root of 1 plus c. Okay, now let's look at this equation. Now, we can solve for c, right? We can solve for c by negating both sides, squaring, and then subtracting 1, but the problem is, if we plug that value of c back into this equation, the statement will never be true. Because in order for this right side of the equation to be a positive 2, the square root of 1 plus c would have to be a negative 2. And we know that that can't happen. We cannot have a square root being equal to a negative number, and at least not in the real number plane. And so this takes us to a dead end. So this will never happen. And for that reason, we can conclude that our equation really needs the positive sign here, and we're solving 2 is equal to the square root of 1 plus c. Squaring both sides, we get that 4 is equal to 1 plus c. Subtracting 1, we get that c is equal to 3. All right, and if c is equal to 3, then our equation, now that we know that this is a positive square root of this expression, will be a positive square root of x squared plus 2 times the natural log of the absolute value of x, and then our c is 3, so plus 3. And so this is our final equation.